Imagine a silent, ancient network, far more complex than any internet we've built. A system where warnings are shared, resources are distributed, and even acts of altruism unfold, all beneath our feet, completely hidden from plain sight. We walk through forests, seeing only individual trees, but what if I told you that beneath the moss and soil, these magnificent giants are not solitary beings at all? What if they're constantly talking, sharing secrets, and supporting an entire community in ways we've only just begun to understand? For centuries, we viewed trees as disconnected competitors, each fighting for its own sunlight and water. But groundbreaking research, especially in the last few decades, has revealed a radical truth. Trees communicate. And their primary internet is a vast subterranean fungal network known as the Wood Wide Web. Think of it as the nervous system of the forest, connecting virtually every plant to every other plant, spanning miles, sometimes even entire continents. This isn't just a casual connection. These fungi, called mycorrhizal fungi, form a symbiotic relationship with tree roots. The fungi are like tiny, super-efficient extensions of the tree's root system, vastly increasing its surface area to absorb water and nutrients like phosphorus and nitrogen from the soil. In return, the tree, through photosynthesis, provides the fungi with essential sugars, energy that the fungi can't produce themselves. It's a perfect trade, but it's only the beginning of their shared story. Here's where it gets truly fascinating. Through this shared fungal network, trees can actually exchange resources with each other. Studies have shown that older, larger mother trees can transfer carbon, nitrogen, and even water to younger, struggling saplings. It's an act of remarkable parental care, ensuring the survival of the next generation, especially in shady areas where young trees might not get enough sunlight to thrive on their own. They don't just compete. Beyond the Wood Wide Web and airborne alarms, trees also communicate internally, and sometimes with each other, through their own vascular systems. When a tree is wounded, say by a broken branch or a hungry deer, it can send electrical signals, remarkably similar to our own nerve impulses, though much slower, through its phloem. These signals can trigger defense mechanisms throughout the tree, making it tougher for future attacks. It's not just about what they share, but who they share it with. Researchers have observed that trees often prioritize their own kin. A mother tree is more likely to send resources to its own offspring than to an unrelated tree. This suggests a form of kin recognition. They can distinguish their own family members from strangers, making the forest less a homogeneous block and more a complex tapestry of related family groups and their fungal allies. The discovery of this intricate communication system has profound implications for how we understand ecosystems. It challenges the very foundation of our individualistic view of nature, revealing a deeper, more interconnected reality. It's not just a collection of trees, it's a superorganism, a vast, breathing, communicating entity that spans incredible distances and generations. We're only seeing the tip of the iceberg, or rather, the leaves of the canopy. But here's the strange part, the mid-twist that deepens this mystery. What happens when a tree dies? Does its network simply vanish? No. In fact, a dying tree can actually offload its remaining carbon and nutrients into the fungal network, essentially donating its final resources to the living trees around it. It's a final act of generosity, a recycling of life that sustains the forest, even in death, demonstrating an incredible resilience built on shared infrastructure. This legacy transfer ensures that nothing is wasted. Even a dead tree, stripped of its leaves and branches, can continue to nourish the forest for years, sometimes decades, after its apparent demise. It feeds the very network that once sustained it, a testament to the continuous cycle of life, death, and rebirth within this hidden forest intelligence. It's a communal bank account of resources, always being topped up, always being drawn from. These discoveries completely reframe our understanding of forest management and conservation. Clear-cutting forests, for example, doesn't just remove individual trees. It severs countless connections, ripping apart this ancient, intricate communication network. It's like unplugging a supercomputer, disabling the very system that allows the remaining trees to thrive, share, and defend themselves. It creates a silence where there was once a symphony of whispers and warnings. The Wood Wide Web isn't just about trees. It's a foundational element of the entire forest ecosystem, supporting a complex web of life from bacteria to insects, shaping the very air we breathe and the water we drink. It shows us that nature operates not as a collection of separate parts, but as a deeply integrated, self-organizing system, where cooperation is often more vital than competition. So, the next time you walk through a forest, remember that beneath your feet, an unseen conversation is constantly unfolding. Trees are sharing resources, warning each other of danger, and even nurturing their young through a subterranean internet built by fungi. They are not just silent, solitary giants, but members of an ancient, intelligent, and interconnected community that has mastered communication over millennia. What other hidden languages are spoken in the natural world that we are yet to discover?